Hello everyone, you are welcome to my YouTube channel. In this channel, I teach civil engineering and structural engineering basically, and then I teach CAD softwares. Likewise, I make reviews on CAD softwares and I make my recommendation based on the review. I also make reviews on the fundamental knowledge of civil engineering. So if this is your first time coming to my channel, kindly leave a subscription behind. In this video, I will be introducing to you an automatic RC detailer that has been developed with LISP programming and Excel VBA. This program was developed by Paulo Marinho, a friend and a colleague from Portugal. So what I'll be showing you in this video is how to use this automatic RC detailer. For this particular video, we'll be working on the beam. Then for the series of videos, we will be working on other structural members. Alright. Then after watching this video, if you are interested in getting the program, you can just contact me with any of the contact details that I'll be putting in the description box of this video. So let's just kickstart as soon as possible. Now I'll go to the Excel template. There is a template for this program. This template will come along with the program when you get it. This program is capable of detailing a beam up to 8 spans. Okay, you can see the span. You have span 1, and then the last you have here is span 8. So you can have up to 8 spans of beam. Usually you shouldn't have more than that, but if you have more than that, can you still use the program? Of course you can use the program. Just as the program is an automatic detailer, it is as well user defined, which means you can literally detail your beam, your column, or whatever you want to design based on how you want it. So you can do that. This particular video will be about the automatic detailing. Then in the next video, I will still be teaching you how you can detail the beam. However, I will be showing you how you can use the user defined functions. Alright, so let's just begin with this. Now for this particular tutorial, the number of spans I'll be choosing is 3. 3 spans should be enough. Or let me even reduce it. Let me just use 2 spans of beam. Okay. Now there are 3 sections to this. Number 1 section is you have to give the geometry of the beam and the geometry of the column that is at the top of the beam or at the bottom of the beam. The second section is you have to give the details of the link, which is the stirrup. And the third section is you have to give the detail of the main reinforcement, which includes the angle bar and the bottom bar. And how do you do that? You can either do that one after the other, or you do it one at a time. Here you have B cross H, which means your breadth and your height. Now if you want all of this beam, I only have 2 beams. If you want this first beam to be 230 by 450, and you also want the second to be 230 by 450, all you just need to do is come here and say 230 by 450, and then you click on this button. What if you want to change them one by one? It is not a big deal. You just come here. You can see this is 0.23, right? And then this is 0.45. Let's assume you want to change this to 0.23 by 600. So you just come here and say 0.6. Okay. So if this is also a 0. Let's say something, you just change it, and then if you have more, you keep changing like that. So this is how you'll be changing them one after the other. However, I'll prefer to make this to be 0.45, okay, and then I can make this to be 0.6, okay. So that is good enough. Then you can move to the next one. The H simply means the vertical difference at the top of a beam, okay. Now when you come to the second beam here, you see this particular beam is 450 deep, while this is 600 deep, which means this particular beam in the second span is deeper than the first beam. And the difference in the depth of the 2 beams is 150 mm, because when you subtract 450 mm from 600 mm, you'll be left with 150 mm. Now the program wants to know how you want the 150 mm to be distributed. Do you want it to be distributed to the top or be distributed to the bottom? Okay, so let's say for example, if you want the top of all of the beam to flush, okay, that means your DH will be equals to 0. Then the 150 mm difference will be added to the bottom of this column. Okay, so you just see that the bottom here will be deeper, but the top of the beam will be level. So that is how you work with DH. However, I want my DH to be equals to 0. Okay, then AS is the width of the column. Okay, the width of the column at the top. So you can see my column here, AS, it is equivalent to 0.23. okay, so that is what I want my column to be. And then AI, I want my column to be 0.23 as well, the column at the bottom. The section of the column at the top of a beam may be different to the section of the column below the beam. However, I want them to be the same, and then I will change it to, let me just change it to 0.25. So all of the column at the top is 0.25, then all of the column at the bottom, let me make it to be 0.23. okay, if you want to change that, you can change that. Then we have two spans. The span of this is 3 meter, while the span of this is 3 meter. So let me make this to be 3 meter, and let me make this to be, let's say, 3.5 meter. Okay, so you change the length of your span. And after changing it to 3.5, make sure you click on this so that it will get activated. Then you can now see this is 3 meter, while this is 3.5 meter. Alright, so now we are done with the geometry of the beam and the geometry of the column. We can then move to the second section, which is the stirrup. Okay, if you look carefully, you will see there are two categories of stirrup. There is one which is basically stirrup, nothing added, and then this one you have stirrup at the left and you have stirrup at the right. Stirrup simply means link. Okay, that is the shear reinforcement. Now the stirrup that is basically stirrup here, that means the stirrup at the mid span. The stirrup at the mid span. While the stirrup at the left and the stirrup at the right, they are the stirrups at the support. Basically, the moment at the end, that is at the support of the beam, is usually higher than what you have at the mid span, unless if it is a simply supported beam. And at the end of the day, you will be requiring a lesser spacing of links at the support compared to what you will have at the mid span. So that is why you are having this diversity. Now in this case, I will decide to use the same spacing for each span. Alright, then I will use a 10 mm stirrup, and then the spacing, I'll make the spacing to be equivalent to 0.15 meter, which is 150 meter. And then the stirrup at the left and stirrup at the right, just as I've said, I will use the same thing. So I can have, so if you are done, then just click on this so that it can be activated. Without clicking on this, there will be no change. So make sure you click on this. That is when you will give the command, because this is a CMD box. Okay, then you have L. Just as I've explained right now, you have two different sections in just one span of beam. That is, you have the mid span section and you have the support section. So there is a particular distance from the face of the column along the mid span of the beam that is regarded as support span, and then what you have at the middle is now the mid span. Now, depending on your containment, and definitely your containment depends on the diameter of your reinforcement. Now, depending on your containment, you will know the particular length that falls under the mid span. You know what falls under the support span. Okay, so now I've decided that the distance from the face of the column up to a distance here, which is 1.2 meter, is what I want to regard as supports. You understand? So all my support reinforcement can only end at this point for the bottom reinforcement. Okay, and then the same thing here, I want to use 1.2 meter. If that is fine, you can just put your 1.2 meter here, and if you want to use beyond that, let's just say you want to use 1.25. okay, so just click on this to activate that, and then you see this has changed to 1.25. This has also changed to 1.25. The same thing for this and the same thing for this. And then what you've just done, you will do the same thing for the top. So let me just assume that I have 1.3 meter for the length of my support. Okay, that's the containment. So this is 1.3, right? Then just click on 1.3. Now you see everything will change to 1.3. You can see this is from here to here 1.3, from here to here 1.3, here to here 1.3, and then here to this point is 1.3. all right, so that is good enough. Then another thing you have to change here is L1 and LN. L1 means the first length and LN means the last length. Okay, now you know this support, this is a support, right? So you'll be having a support reinforcement. Also, this is a support because you're having a column, that's a support, so you'll be having a support reinforcement, and the same thing for this. But what is happening here is different from what is happening here, simply because this is an interior support, whereas this is exterior support. Okay, now if you look at the continuity, this particular interior support is continuous to the right, also continuous to the left, whereas this is continuous to the right alone, and this is continuous to the left alone. So that tells you you will have different support lengths. Okay, so if that is what you are having, the program is still capable of changing that. Okay, so all you just need to do is let's say it is 1.2, just come here and say that your first and your last leg, they are different, they are not the same thing with all of this. So you have to make a difference between this, and then you click on this. Okay, so your first, you can see my first has now changed to 1.2, whereas this will keep being 1.3, this will also be 1.3, and also the last leg will be 1.2. Now you can see the dynamic of the program. All right, so now we are done with the stirrup, and then we can move to the main bar. All right, the main bar, definitely you should know we have the anchor bar, which is the top bar, and then you have the bottom bar. This is the reinforcement for your bottom bar, and this is the extra reinforcement for your bottom bar. Now let's take a look at this. This is a 230 beam. The width is 230 mm by 450 mm. Now the 230 mm, you have to remove the cover, let's say a cover of 25 at each side. Then from there, you know what the length of your link will be. If you now have 5 reinforcements, if 5 reinforcements is what is designed for, definitely you cannot arrange 5 reinforcements in just one layer. So all you can do is, first of all, you can arrange 3 reinforcements at the top, and then under that 3 reinforcements, you can put another 2 reinforcements, but it will still be at the top. Then you can now separate that 3 numbers of reinforcement at the top and the 2 number of reinforcements at the bottom with a spacer. Okay, so that 2 reinforcement that you're having at the bottom, it is an extra bar. All right, and then that is what you are having at this side. Okay, that is what you're having at this side. So now let's just assume that is what we have. We have 5y16 at the top. So I will change the number here to 5. Sorry, I will change the number here to 3. Okay, and then I'll make this to be 2. Okay, let me make this to be 20 mm. Then I will click on this equal to sign. Okay, this equal to sign, so that the first and the second can be the same. And then I also click on the equal to sign so that this and this will be the same. Now I am done with the bottom reinforcement. Then I can move ahead with the top reinforcement. I can use this same thing. Let me just use 3y20. Okay, then I will click on equal to sign here so that this and this can be the same, and then I'll make this to be 2y16, and I will click on the equal to sign. Then everything can be the same. Of course, the program will also draw the cross section. It will not just detail the elevation of the beam, it will as well detail the cross section so that you can see the link and everything like that. So for it to do that, it will need the thickness of the slab. So you can insert your thickness of slab, but a slab at one side may be deeper than the slab at the other side, so there might be a diversity, and that is why you have to input the thickness of the slab at both sides. Okay, so if that is done, just come to the top here, and then you just click on save file. Okay, so when you're done saving your file, then you can go to AutoCAD. Now I will just delete this. This is what I had before. Okay, so now in AutoCAD, you will come to the 2 palettes here. When you contact me to get the program, I will show you a video of how you can install the program, and then you can do all of these 2 palettes, everything at once. Okay, so now you look for the beam. Now this is beam. Okay, this is longitudinal beam. You click on it. After clicking on it, all you just need to do is drop. Okay, now after dropping it, you will see what you have. Now you can see they have 3 different layers. This particular one is you can see this particular one is 3y20. That is your main reinforcement. Okay, and then this particular one, that is 2y16. Okay, and then the length, you can see the length here where the length stops. You can see the length stops as 1.2. You were the one who did all of these changes. So you have all of this as it is, and you can see this is deeper. We use 600 mm change here. Then you can see your link. This is the link at the center, which is 10 mm at the spacing of 150 mm, and then like this. You can also make your changes. Let's say you are not comfortable. This is 2 diameter 16, right? For example, if you wish to have it like 2y16 or 2t16 or 2r16, all you just need to do is you click on this, and then you click on select similar. Okay, then you see it will select this 216, select this 216, and then also this 216. All the 216 that is here, it will select it. So after selecting it, just double click. Now after double clicking, you will see this block reference. There is a block reference that has been made with this program, so you don't have too much problem. So now you will see the text here. The text is 216 whatever. So just change the diameter sign, and then you change it to y. My keyboard is acting weird, so I'll just use my on-screen keyboard. I don't know why that is, but we can use the on-screen. So here I will change this to Y. Okay, so that is good enough. Now you can see this has changed to 2Y16. The same thing for this and the rest. Then another thing you can change is the layer. We have a layer for reinforcement 16, which is Y16. So if you want to change the layer from this particular color to something else, let's see, you can see this is the layer for the 10, this is the layer for the 12, this is the layer for 16, this is the layer for 20, this is the layer for 25. Okay, so let me use this layer for 25. Okay, I will use it for that same beam. It will not change the diameter of the beam. Put that in your mind. It will not change the diameter of the beam. It will just change the layer, because there are some layers that has been assigned to different diameter of rebar. So it will change the diameter, it will change the layer, but it will not change the diameter. The diameter will still remain as it is. Okay, however, you can still change the visibility. Now let's say this particular one, which is this particular extra bar, let's say it does not have a hook. Okay, so but you can see there is a hook here, so you can change that. Just come to visibility, and then now to get that, this you can see hook 0 degree, hook 0 degree. That tells you that there's a hook of 0 degree at the left and there's a hook of 0 degree at the right. This means there's a hook of 0 degree at the left and hook of 90 degrees at the right. As you are doing that, just be checking what you have here. It will be showing. Okay, so you don't need to really bother yourself. However, I will use without hook at the left, and there's a 0 degree hook at the right. So you click on this. Okay, now you can see there is no hook here, and also there is no hook here. Okay, saying a 0 degree hook is still the same thing as there is no hook, because the 0 degree is 180 degree, is still straight line. Okay, so if that is fine, then you can just leave that, and then you close it. Okay, then you can do the same thing for this. It can still be shifted, so it can be shifted, just shift it like this. Okay, so if you want to shift it like that, and then many more. And then this as well, let me just click on it and then say select similar, and then just double click on any of them, and then this I'll change it to, okay, I'll still have to use my on screen. Then you just have to bear with me. Then I will use this particular one, I will take it away, then I'll use Y. Okay, and then I think that's just enough. I don't need to change more. So that is how you go ahead to change it. And then your link, let me close this block. Your link, let's select similar, and then you double click on that. Then the text, I will change the text to Y10, and then this particular one I will edit it and make it become like this. Okay, and then the spacing of 150 mm, 150. Okay, and then I will just write link. Okay, links as a caption. Sorry, I wrote kinks. Links. Okay, so I think that is good enough. Then you can close that. You can close the editor. Okay, then you can see you have it like this. Okay, and then when you zoom closely, you see that this is it is clashing with this dimension. So just select this like this. Okay, and then you can just click this particular one. You can see forward arrow. This forward arrow, when you click on the forward arrow, it will automatically take you to the other direction, so you don't even need to move or do anything like that. Okay, so I think that is good enough. And then another thing is the lapping. You might be wondering if there is no lapping. There is lapping actually. You can see this is one section here, right? And then this is another section. Okay, so all you can just do is you can click on this particular one. You can click on it like this. Okay, and then you can use your move tool. So just move it, so let's say around here. Okay, now when you look carefully, now you see there is a lapping. Okay, so that is looking good. And then you can also check your section here. You can see how you have your sections. You have your 3 rebars, and then you have 2 rebars like this. So for it to be more proper, you can just take this one, and then let's say this one, and then you move it downward. Okay, because you can always adjust this to make it look more easy. Okay, so this is what I was saying. So you have your 3 at the top, and then you have 2 at the bottom. So you do the same thing here. You select this, and then use your move tool to move it upward. Okay, something like this. All right, so that is making more sense. And you can do the same thing here. Also, you can change the diameter to Y, just as I've shown you. So you can do all that. So you can see how easy it is. So if you are interested in getting the program, you can just contact me, as I have said. And if you like this video, make sure you give it a like. And if this is your first time on this channel, you have not given me a subscription yet, kindly consider giving me a subscription, because in this channel I have enough content and I'll still produce more content that will help you as a structural engineer. So you'll be gaining more from subscribing. Thank you for watching, and thank you for always coming.